chapter 15 deals with the behavior of weak acid and weak bases. But before you can deal with the behavior of weak acid and weak bases, there you have to know how we define acid and base. So this is, we're not going to cover the entire chapter, rather we're just going to cover the basic definition of the acid and base there. And in terms of the homework assignment there, since you finished, we're going to be finishing this particular chapter. Now there are questions assigned in homework number 3, and as I told you there, the minimum amount of work you have to do for homework number 3 is chapter 9, chapter 10, the first 2 learning objectives of chapter 10. 11, 12, 15, you can do as many as you prefer, or you can do as few as you want, or not doing them at all. But again, as I always try to tell the class there, when I teach a class there, exam is very important. What you will be tested is very important. But more important than that is the topics that we cover in there. So you don't just study for the exam, rather you need to make sure that you pay attention to the materials that we cover in this course there. And even if you are not being tested, when you don't have the time when you're preparing for the final exam there, I understand you can skip these things for now. But after the final exam, please make sure you take the time to read through it. Make sure you understand these basic definitions. And the reason I want to emphasize that is because I talk to other faculty members on a regular basis there, and they always say, when we get into chapter 15, this particular topic in Chem 102, when we started talking about acid base, and students in the class there, most of them will say, well, we've never had this before. I said, we had them in Chem 101. We talked about acid base. So this is something that you do need to know when you get into Chem 102, something that you do need to pay attention to. Okay, so talking about the acid base there, we have to know how do we define a particular compound as an acid. And also, since chapter 15, the focus is going to be on the behavior of weak acid, well, we want to know, how do you differentiate, how do you define what's a weak acid, what's a strong acid there. And what happens when you dissolve an acid in water and the acid gives out something, what do we call the leftover? And we use the term conjugate acid and conjugate base to describe whatever is left after the donation or reception of the proton there. So we want to give you an idea of what is a strong acid and strong base. Now, when you talk about the acid there are only 6 known strong acids. Everything else would be a weak acid. Okay, so here hydrochloric acid, HCl, hydrobromic acid, HBr, hydroiodic acid, HI. Okay, nitric acid, perchloric acid, citric acid. These are the only known strong acids. And this is something that I actually need you to memorize. We will ask you questions on the final exam. Which one is a strong acid or which one is a weak acid? Well, if you know, these are the only 6 strong acids, and everything else will be a weak acid. Okay, so this is a table in chapter 15, and we need you to remember there. And when you look at the review sheets and study guide for the final exam there, we actually talk about that. What are the 6 strong acids? Well, you need to know their name, you need to know their formula. And these are the only 6, these are the all the strong acids that we know of. Okay. Everything else will be a weak acid. Vinegar, acetic acid in vinegar, that's a weak acid. Okay. Ammonia, that's a weak base. So we want you to, when you look at the acid there, we try to put a different color on the hydrogen there. And we will talk about that definition. And when we talk about the definition of the acid there, we will show you the importance of that colored hydrogen there. You have to have at least one hydrogen attached to the most electronegative elements in the molecule in order to qualify for an acid there. So these are the 6 known strong acids, and everything else will be a weak acid. Now, how do we define acid? How do we define base? Well, in chemistry, in the area of chemistry, there are many different ways to define a particular chemical as an acid or a base. One of them is what we call the Bronsted-Lowry definition. And also, when you get into organic chemistry, you will hear Lewis definition, the same Lewis, Gilbert Newton Lewis. Will give you the Lewis structure and all that theory there. So we have Lewis acid and Lewis base. And Bronsted-Lowry definition focus on what happens when you have a compound that can be called acid. An acid is a substance that can donate meaning given out. A hydrogen ion. Well, hydrogen ion, H+. Hydrogen has one proton, one electron. When you lose that one electron, the only thing left is the proton. So you see the term proton for H+, and you also see the term hydrogen ion. They mean the same thing. Okay? So acid would be something that can donate a hydrogen ion. So you have to have a hydrogen ion with you to begin with. Otherwise, if you don't even have a hydrogen with you, you cannot donate hydrogen ion. So that's how we define an acid. Bronsted-Lowry definition says a substance that can donate a hydrogen ion is an acid. Okay. Examples of acid there: HNO3, nitric acid, one of the 6 strong acids. Acetic acid, CH3COOH. Now, there are 4 hydrogens in acetic acid. Only this hydrogen is responsible for the acidity of the compound. HNO3. Now, hydrogen is attached not to nitrogen, but to oxygen. Hydrogen is attached to, if you draw the Lewis structure there, you will see hydrogen has to be attached to the most electronegative elements. Okay, so that's the acid there. Now, looking at nitric acid versus nitrous acid, HNO3 versus HNO2, you can see hydrogen is attached to the oxygen. Hydrogen is attached to the oxygen there. Because nitrogen is group 5A, oxygen is group 6A. Electronegativity-wise, oxygen is more electronegative. It's on the right side of the periodic table. Okay, so hydrogen has to be attached to it. And if you look at the acetic acid there, CH3COOH. Now, this hydrogen is attached to the oxygen. This hydrogen is responsible for the acidity or the acid property of the acetic acid there. So in this case, an acid, put it in red, you have to remember this. Acid must have a hydrogen bounded to an element of high electronegativity value. Okay, so when you have 2 different types of elements in there, and with a hydrogen, which one is the hydrogen going to attach to? Well, look at the group number for those 2 elements there. Whichever has a higher group number, meaning a higher electronegativity value, hydrogen is going to go with them. Okay, so hydrogen must be attached. You must have at least one hydrogen attached to the element, the most electronegative elements in there. You can have more than one. Like sulfuric acid, H2SO4. In that case, both hydrogens are attached to oxygens in there. Okay, so different oxygens, you have 4 oxygens in there. So both hydrogens are attached to oxygens, and both hydrogens are responsible for the acidity. Okay, so again, you must have at least one hydrogen bounded to an element with high electronegativity value here. Now, the question here is that when we look at different species in chemistry there, we must be able to differentiate whether a particular species is going to be an acid or not. So nitrate ion, can this be a Bronsted-Lowry acid? Well, the definition says something that can donate hydrogen ion. If you don't even have a hydrogen ion in there, it cannot be an acid or a Bronsted-Lowry acid. Bronsted-Lowry acid. So this one cannot be NO3, cannot be. HNO3 is an acid, but NO3 minus, that's not an acid there. We will have a proper term for the NO3, nitrate ion, when we get into the next section there. So talking about the acid, the other side will be base. How do we define a base? Acid is defined as something that can donate hydrogen ion. Well, base is a substance that can